TGIF, am I right? It's an iterative process, Tony. We are indeed doing a review for the module. Happy birthday. Happy birthday to Ashna's dog. Okay, so yeah, so we're reviewing for the module today. So you should have all gotten an email from Tabes, and I think he just sent out another one. Oh, no, that was just me, not Al. I mean, the written module is basically like it's like a written homework. Like it'll be, I think it's four. Let me check. So it's like four questions. They're broken up into parts. Generally, like the first part of it is asking you to compute something. So that's not really any dissimilar from stuff you've already done. And then the next part will ask you to maybe explain something about your computation, like why does it make sense to do it this way, or stuff like that. We'll see some examples in the review. Yes, you have to do both the written and the MyMathLab quiz. Yeah, the MyMathLab quiz is timed. It's 60. You have 60 minutes to do it, but you can also retake it once, and then we'll just take the highest grade. Mm-hmm. I think it'll essentially be available until midnight tomorrow. So you would want to start it before. Yes. It's not up to me right now, Emiliano. Lo siento. That's basically correct. Yeah. So it's like once you start it, you have 60 minutes to do it. If you have accommodations, then your time will be extended. Um, I think there's five modules. One every week. All right, so let's begin. Um, I'm not entirely sure. So this worksheet is on Blackboard under my tab. I posted it just a few minutes ago. Okay, so let's look at the first one. And I'll break out into groups in a bit to do a few of these as well. There's a lot. I don't know if we'll do every single one of these because there's questions on the second page that are just as, if not more important. But let's look at the first one. All right. So I want to take the derivative of e to the -3 cosine x. Okay. So what rule am I going to use here? So there are things like, I'm thinking about things like, right, the chain rule. Okay. So what will the outermost function be? Yeah, so e to the x or something like that. So where we want to write this as a composition of functions. So this is something you'll need to do. Like you'll need to say like so I could say that f of u is e to the u, g of x is -3 cosine x, and then f composed with g of x is e to the -3 cosine x. Right, you could use logarithmic differentiation here, but you wouldn't need to. Okay, so then recall the chain rule says that the derivative of a composition is the derivative of the outside function evaluated at the inside function times the derivative of the inside function. Okay, so what is the derivative of e to the u, or e to the x? Good, just e to the u or e to the x, right? So the derivative of e to the -3 cosine x, this term, f prime evaluated at g, will be e to the -3 cosine x. Okay, then you multiply by the derivative of the inside. All right, yeah, and the derivative of the inside will be 3 sine x, right? Because the derivative of cosine is negative sine. The negative cancels out with the negative in front of the 3, and you just sort of leave the 3 out front. Okay, good. So we've computed one derivative. Yes. All right. So I'm going to break out into groups, and I want y'all to look at, let's see, say the next 3. So state like what rule you're using, and then maybe like label the function. So for example, if you're using the product rule, you would want to call one of them, say like which function is u, and which function is v. Okay? And then myself and the LAs can come around. Yes, you could put the 3 out front. Oh my God. This is good work. So let's see. For C, you said? So we take so walk me through like what you're doing, or how did you get that? Uh-huh. Right. Yep. So what's the derivative of the inside function again? Yep, exactly. Yeah, yeah. Right. Good. All right, so Uh, yeah, something like this is fine. Yeah. As a single fraction. Yeah, either one. Yeah. Yep. Good. Okay.
So let's get back together here.
Okay. So for the second question, what rule would we use? So we would use the chain rule. So the -3 e to the x is the argument of the cosine function, right? So our outside function is just cosine, and our inside function here is -3 e to the x. Okay, so when we take the derivative, you take the derivative of the outside function first and maintain the argument. So what's the derivative of cosine? Good, negative sine. And then I leave the argument the same. So I leave this -3 e to the x. All right, then I multiply by the derivative of the outside function. Okay, so what's the derivative of -3 e to the x? Good, just -3. Yeah, exactly. It's just -3 e to the x. Okay, so you could multiply the coefficients. In front of the sine is a -1, basically. In front of the e to the x is a -3. So you could write this as 3 sine -3 e to the x times e to the x. Yeah, either these would be fine, basically. Roger. All right. So let's look at D. All right. What rule would you use for that? Good, the product. So in your explanation, you would say I'm using like you would. So for the part one would be basically compute the derivative, and for that you wouldn't necessarily need to write too much. You could. Just compute the derivative. And then in the second part, you'll explain like what you did. So you could say, I used the chain rule. You could write out like the chain rule. And you could say, my outside function f is cosine, my inside function g is negative 3e to the x. The derivative of cosine is negative sine. The derivative of negative 3e to the x is negative 3e to the x. Okay, in part D, what rule are you using? Good, the product rule, right? Okay, and the product rule says that, or maybe I'll write it in terms of that the derivative of a product something like this, all right? So you could compute the derivative, and in the explanation part, you'll want to say kind of like what you're doing. So I'm using the product rule. Here I've written down the product rule. The first function u is this x to the fourth minus 4x squared plus 7. The derivative of that is 4x cubed minus 8x. The next function v is the natural log of x. The derivative of that is 1 over x. Okay? So then the answer here will be u prime v. So that's 4x cubed minus 8 times v plus uv prime. So that's x to the fourth minus 4x squared plus 7 times v prime, which is 1 over x. Yes, thank you. I don't think so. I mean, no, there's really no way. I mean, I could maybe write the right-hand term as like a single fraction, but there's not really much simplification you can do here. In C, you would use the chain rule as well. Okay, we can come back to these at this time, but I want to get to the other problems too, because this is only like one part of the module. So let's just say maybe like, whoops, you're not invited. To turn off this email thing if I get something odder. So yeah, don't send me emails during class unless you want everyone to see it. Okay, so let's look at so D or E and F, like broadly, like what rule would you use? Good, right? For both of these, you would use the quotient, and I'll post like solutions to this as well. Okay, for G and H, what rule would we be using? Good, the chain in both of them, really, yeah. Okay, in particular in G, there's three functions, right? The outermost function is the natural log, the middle function is sine, and the innermost function is this 6x to the 6th power. Chain. All right, so in the interest of time, though, I do want to move on to these other problems. All right, so question 2 says, consider f of x, which is this polynomial, compute f prime and find the x values where f has a horizontal tangent line. Okay, so computing the derivative here is fairly straightforward. All right, so you just use the power rule, right? So you get 3x squared minus 2x minus 1. So when does a function have a horizontal tangent line? Exactly, when the slope is 0. So this is the kind of like conceptual stuff. So you'd want to say like, well, f prime has a horizontal tangent line when the derivative, well, when the slope of a horizontal line is 0. So f has a horizontal tangent line when f prime is 0. Okay, so you would set f prime equal to 0. Okay, so this will factor as, let's see. Yeah, 3x plus 1 times x minus 1. Okay, so there's two solutions here. One is when x equals 1, and the other is when x equals negative 1/3. All right, any questions on that? Thank you, SR. Okay, so the second part says find the tangent line to this function at negative 1. All right, so finding the tangent line, you'll need like y minus y naught equals m times x minus x naught. All right, where if x is negative 1, the point x naught y naught is negative 1 f of negative 1. And the slope is the derivative at negative 1. Anna. Okay, so to find the tangent line here, you need to basically find out what is f of negative 1 and what is f prime of negative 1. All right, so take a minute to do that.
Okay, good. Right. So you're just plugging in -1 into the original function and the derivative. So if I plug -1 into the original function, I'd have -1 cubed minus -1 squared minus -1 minus 1. All right. So it's kind of annoying. -1 cubed is still -1. -1 squared is 1, so then I have -1. Minus -1 is +1, and then another -1. So I have 3 negatives and a plus, so this is -2.
Okay, to find f prime of -1,
Now you're plugging -1 into the derivative. So we have 3 times -1 squared minus 2 times -1 minus 1. So this is 3 plus 2 minus 1, which is 4. All right, then the tangent line, so this point, or this derivative is 4, the slope is 4, and this point is -1, -2. Okay, so the tangent line is y plus 2 equals 4 times x plus 1. And you can leave it like this. You don't like need to solve for the y.
Mm. Apparently cats can get coronavirus, so make sure they're social distancing. Yeah, that's true. Emmy is sleeping, so probably not. But maybe. I'll let her know. I got x plus 1
Because I'm plugging in -1.
into x minus x naught. Yeah, she's not the best teaching assistant.
Okay, so then finally, part C, find all x values where the tangent line is parallel to the line from part B. Okay, so recall, parallel lines have the same slope. Okay, so if a tangent line to the curve is parallel to the line from part B, what will its slope be? Good, 4. All right, so how do I find the x values where the tangent line will be 4? Or sorry, where the slope of the tangent line will be 4. So if the slope of the tangent line is 4, what is the slope of the tangent line? What's a fancy word for that? The derivative. So if the slope of the tangent line is 4, that means that f prime of x equals 4. So we set f prime equal to 4 and solve. Basically the same thing we did in the first part where we said if it has a horizontal tangent line, we set f prime equal to 0. Okay, so our derivative is 3x squared minus 2x minus 1. So we set 3x squared minus 2x minus 1 equal to 4. Okay, so why don't y'all take a couple minutes and try to solve this. So you'll move the 4 over to the other side, basically, and then try to factor. Yeah, he's got a clacky keyboard. Big clack. Sophia, you're excused. Okay, if you must. I do not, unfortunately. Yeah, I'm bunkered underground. Big science. Yes, we can. Thank you. Okay. So we basically set most of it up. You just solve this. So you subtract the 4 over, you get 3, and you get 3x squared minus 2x minus 5.
Set that equal to 0.
And then you just factor it. So this will factor as 3x with an x minus 5 plus 1. If you're not that great at factoring, that's okay. You have 36 hours to do this, so you can try lots of things. Okay, so you get there's two solutions to this. One are x is 5/3, and the other one is x equals -1. All right, -1 is of course just the where we found the tangent line to begin with. So x equals 5/3 is basically the other x value.
Yes, find all x values where the tangent line is parallel to the line from part B. It would just be 5/3. I mean, you could write, it's like fine. -1 is what we started out with, right? Find the tangent line at -1. Find all x values where the tangent line is parallel to the line at -1. All right, so the last one, compute the derivative of cotangent in 2 different ways. So we've written it basically 2 different ways. Once we've written it, we've written it as a quotient and as a product. All right, so use the quotient and product rules and verify that your answers are equal. Okay, so remember the quotient rule. Low d high minus high d low over low low.
So if we take the derivative here on the left, we'll have low d high, so that's sine of x times the derivative of cosine. I'm out of room here, so let me. And as you've said several times now, the derivative of cosine is negative sine minus
high d low.
So that's cosine x times the derivative of sine. So what's the derivative of sine? Good, cosine. And then all over low low. So that's just sine squared x. Okay, so now let's look. So you will need to simplify here because I'm going to need to show that these two sides are equal. All right, but let's look at the right-hand side now. So again, so here we're using the product rule. So this is the quotient. Here's the product rule. Stop that. Okay, so the derivative of cosine times cosecant. So the derivative of cosine is negative sine. And then we leave the cosecant plus leave the cosine and multiply by the derivative of cosecant. So what is the derivative of cosecant? Good. Negative cosecant cotangent. Okay, so now I want to show that these two things are equal. So I'm going to simplify basically both of them. All right, so the left-hand side, sine times negative sine is negative sine squared. Cosine times cosine is cosine squared. All right, I can factor out a negative. And then I have in parentheses sine squared plus cosine squared. So what is sine squared plus cosine squared?
Good, just 1.
So you get negative 1 over sine squared. And I can write that as negative cosecant squared.
Okay, so let's see if I can recover the same thing from the right-hand side.
So I'm going to write everything basically in terms of sine and cosine. All right, so I have negative sine. Cosecant is 1 over sine. Then the right term is cosine, negative cosecant, so negative 1 over sine. And then cotangent is cosine over sine. Okay, so the term on the left, sine over sine, just becomes negative 1. Then on the right, there's still a negative 1, and I end up with cosine squared over sine squared.
Okay, so there's a couple ways you could go from here. You could write cosine squared over sine squared as cotangent squared and use an identity for that.
Or you could write it as a single fraction, and you'll end up with the same, like if you
Convert negative 1 into being a fraction over sine squared, it's just negative sine squared over sine squared.
So you end up with negative sine squared minus cosine squared over sine squared. Yeah, so really, I mean, you kind of get to the same point here as well, if you do it this way.
Okay, so that's all for our review. I will post
These solutions on Blackboard in like 15 minutes, probably.
Yep. Good luck. How did negative 1 turn into that? So I just added them. I basically added them as fractions.
I wrote negative 1 as negative sine squared over sine squared.
Then I have two fractions with the same denominator. The written module will be posted on Blackboard. Yeah, I'll post a filled out version. All right. May God have mercy on you. Wash your hands. Good luck on your module. There you go. All right, bye guys. So I mean, it'll basically cover similar things, like stuff about tangent lines and product rule, quotient rule, stuff like that. Yes. Question. So it basically covers the stuff we reviewed today, yeah. Like product quotient rule, um, chain rule, thinking about the derivative as the slope of a tangent line, stuff like that. Derivatives of trig functions. Just, yeah, kind of stuff from a while ago. So I added -1 to it, basically. I converted -1. I rewrote -1 as negative sine squared over sine squared. Yeah, you can use yeah, that's right, Natalie. You can use that identity as well. That's another way of getting to this answer. No, you have until tomorrow at midnight. Send me an email, Praveen. It won't be on my math lab. It won't be posted till 5 p.m. Yep. Yes. The written module will be posted on Blackboard. Mm-hmm. It's timed in the sense that it's due tomorrow at midnight. It'll be posted at 5 as well.